Okay, so today we're going to do an exercise from Cambridge A-Level Maths 9709, paper 41 from May-June 2020. And exercise 3 says the following. A particle P is projected vertically upwards with a speed of 5 meters per second from a point H, which is 2.8 meters above horizontal ground. Find the greatest height above the ground reached by P. This should be fairly straightforward if you've done enough exercises. It's an object thrown vertically. The first thing you should do in all these types of exercise is a drawing. So you have something like this. This is 2.8 meters. And something is thrown upwards with 5 meters per second. Okay? So remember that the condition for something reaching its greatest height is that the speed at the top, the velocity at the top is 0. That's why it stops. It's finished its energy. It slows down until it gets to 0, and then it starts dropping down again. Okay, so if we use the third equation of motion, which is v squared equals u squared plus 2as, and we use that v squared is 0. So 0 equals 5 squared, and then we have to take a look if we are considering something going upwards, we can use as our y-axis going upwards and x-axis going to the right, which we're not going to use in this exercise. So y-axis going upwards, and the gravity is going downwards. Okay, so the gravity in this case is negative. 0 equals 5 squared minus 2 times 10 times s. So s equals 25 divided by 20. Okay, so s equals 25 divided by 20. That's 5 divided by 4, which is 1.25. So s is 1.25 meters, but obviously that's counting from where we've thrown it. So the s, if we look at if we measure from the bottom, and all our measurements should be from the bottom, is 1.25 plus that 2.8, which is 4.05 meters. So that's our greatest height. So now, B, the length of time for which P is at a height of more than 3.6 meters above the ground. Okay, so if we consider our axis here, now, I'm doing it, we could do it above, but I'm going to do it here so that you learn how to use that too. What they're saying is that there's going to be a height here, which is 3.6 meters, and our object is going to go upwards, so it's going to surpass that height, and then it's going to go downwards, and they want to know that time between when it was going upwards and downwards. Okay, so so what we want to we can use the first equation of motion, the second equation of motion, sorry, the one with distance. So distance equals initial distance plus initial speed times time plus half acceleration times t squared. Okay, I know in most cases, most books, you don't have this initial space, but remember that if we already have a 2.8 distance here, height here, we have to add it up. So it's as if we were doing everything from here and then added up this initial space like we did before. But now we're including it in the formula. So if you're not comfortable using this S0, you can do all the exercise as if you were starting from where you threw the object and then add 2.8. I'm going to do it already from here. If you start here and where you throw the height at the height where you throw the object, the distance that they want is not 3.6, it's 3.6 minus 2.8. So in order not to, so I want to do it with the 3.6 so that you don't get too confused. But again, you could do it from here and doing it with a distance of 3.6 minus 2.8. So if we do it with a whole 3.6 distance, we have to consider that it's being thrown from the ground, so it already has a 2.8 there. So what do we want to know? We want to know when it crosses there. So when it crosses there, it's and we're using this formula because they're asking for the time and they're giving us distance. So we have a space here, which is 3.6, an initial space of 2.8, an initial speed of 5, the time we don't know it. Acceleration is going to be gravity, so that's 10 divided by 2, and that's t squared. Okay, so basically what we have is a second grade equation that's 5t squared plus 5t minus 0.8 equals 0. So if we solve that second grade equation, we obtain with a calculator or with your second grade equation formula, you obtain 2 times, which is 0.8 seconds and 0.2 seconds. What does this mean? It means that it crossed the distance of 3.6 at 0.2 seconds, went up and then started falling down and crossed that distance again. So the time that we've been asked for, which is the length of time, is 0.8. That length of time is 0.8 minus 0.2, which is 0.6 seconds, and that's our length of time.